Okay, lesson 4, power to power rule. So this is kind of our second rule that involves a product looking type of problem. So when taking an exponent to another exponent, a power to a power, you multiply the two exponents together. So just to recap, the product to a power rule makes you add the exponents. The power to a power rule makes you multiply the exponents. So go ahead and write in our power rule example, steps and things to remember. Step 1, you're always going to multiply the exponents. Step 2, you're always going to keep the base the same. Give you a second to write down those two things, and then I'm going to talk about our first example. In example number 1, you can see that the base is x, therefore I'm going to keep it the same. And I can see that the exponent of 3 is being raised to an exponent of 6, a power to a power. Therefore, I'm going to take 3, multiply it by 6, and get x to the 18th. And that is your answer for that. That is a very simple one. There's no coefficient. The base is a variable, so you just have the variable base with two exponents being multiplied. Now in the next example, this is a power rule with a coefficient. Remember, and I know we've talked about this a lot lately, you're only applying things to each term separately. So if you want to write yourself that thing to remember, apply the power to each term separately. And I am going to take a minute here to talk about each of the terms within the parentheses of these examples. So in the first example, there is one term of 2 and a second term of x squared. So when I apply this 4 power to it, I do it twice. So I'm going to show my work a lot in these first couple examples, and as we get to the more complicated ones, I'm going to just talk about it and write down my work as I were doing it in my head, and I know a lot of you will do the same for these easier multiplication. So I'm going to say 2 to the 4th power, and then x 2 times 4. So I obviously have to expand out that 2 to the 4th. So I could show that in my work, 2 4 times. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Keep my base x, and then I do 2 times 4, which is an exponent of 8. So 16, 8, say that again, 16x to the 8th is my final answer. In this next one, we have a few more terms that the power has to be applied to. So we're applying the power to the 3, because it's separate as a coefficient, to the x to the 7th, and to the y to the 3rd. So if I'm showing this, 3 to the 3rd, x 7 times 3, y 3 times 3. So expand out 3 times 3 times 3, which is 27. X becomes 21, and y becomes 9, and that is your final answer. Now we're going to take both of our product rules and we're going to put them together. So I'm going to apply my power rule, then my product rule. So in example number 1, I have to take this power of 3 over to the 4 before I can do anything else. So I have n 4 times 3. The n to the 5th just is brought down, kind of like when you're doing order of operations and you bring down most of your work in the first step. Second step is to show that I get 12. I'm still bringing along that n to the 5th, and now I can use my product rule to add n 12 plus 5, which gives me n to the 17th. I know most of you do not need some of these intermittent steps, like showing 4 times 3, showing 12 plus 5, that you can just do that, and that is quite okay. I just want to make sure in your notes you know exactly where my numbers are coming from. In this next one, we have some coefficients to deal with. So I have an exponent of 5, and then I also have to deal with my exponent of 3. So I'm going to make sure I keep everything within my parentheses. So I have 2 to the 5th, and then I have a 3 times 5, and I'm going to close those parentheses. I'll simplify in a minute. Then I have 3 to the 3rd, a to the 3rd. Now that's just going to become an a to the 3rd. There's nothing you have to multiply, technically a 1, but you could just stick that 3 on the a and that's it. and then b 2 times 3, close your parenthesis. So you're going to run into, sometimes you guys probably could have done some of this in your head, but I would say that you want to be pretty careful when you're expanding out these 2's. You should know from the previous 2 to the 4th is 16, so 2 to the 5th is going to be 32. And then that a becomes a to the 6th. I technically still need that in parentheses. Then 3 to the 3rd becomes 27. The a to the 3rd comes down, and the b is multiplied to become a 6. Now I do need to deal with my product of power rules. I've taken care of all of the power to power work. Now I'm going to pay attention to multiplying my coefficients to get 864. I'm actually going to write that in another color just so you guys are clear where the answer is coming from. So 864. I'm going to take care of my a bases by adding the 6 and the 3 to get 9. And then my b base can't be added to anything, so it just comes down. And I have a final answer of 864, a to the 9th, b to the 6th. I cannot simplify that anymore. The next step we're going to do is we are going to put all our rules together. So I've made you a list with kind of shortcut reminders. They are in no particular order. So again, the power rule means to multiply. The product rule means to add. When we're speaking of a negative exponent or the negative rule, remember we have an upstairs and a downstairs. We have to create those or sometimes just move around our negatives to make them positive. And then anything to a 0 power becomes 1. So we call that the 0 rule. So all of these right here are just kind of shortcut reminders for you, no particular order, and like you don't have to do these in this order. So we're going to go to the first example. First example, I have a power to a power. So I have to apply that power to every single term separately. So I'm showing you highlights of the terms that I see. So there are 3 within my first set of parentheses. And I'm going to kind of just do the multiplication out loud. So I have a, 3 times 6 is 18. B, we just put the 6 power on. It's like you're multiplying 1 times 6. And C becomes 2 times 6, which is 12. So there's your first set of parentheses. In your second grouping, you have a b to the negative second power as well as a c to the 0 power. And yes, you can apply a power with a negative with an exponential power. So I come down, I bring my parenthesis, I say b, negative 2 times positive 3 gives me negative 6. And then c to the 0 is technically, equal to 1. And 1 to the 3rd power is also equal to 1. So I'm going to write you a little note over here. Follow along this way. Therefore, I have simplified that c all the way down to 1. And if I multiply b to the negative 6 times 1, it's still b to the negative 6. Therefore, that c is completely gone. It's simplified out to 1. Now I can take care of my negatives. Can't do anything else with a negative. Therefore, I have to create my downstairs party because there isn't one. Everything positive stays on top. Everything negative has to go downstairs to become positive. And the one thing I can simplify through is these b's because they are equal to 1. I can say a to the 18th, b to the 12th is my final answer. That does not happen all the time. So if you have b to the 5th over b to the 6th, at this point you should be leaving it alone, but because these go down to 1, you can take them out. All right, in our last example, let's identify those terms so we make sure we're applying our power of 3 correctly. So I have a negative 5, I have a x to the 3rd, and I have a y to the negative 4th. So I'm going to apply that power of 3 to each of those. If you need to come over to the side to do that power not in your head, do so you don't mess up those negatives. So I get positive 25 times negative 5, which is negative 125. Now I apply that 3 to the x, so 3 times 3 is 9. I apply that 3 to the negative 4, which is y to the negative 12th, and I keep my parentheses. I don't have any powers over here, so I can technically just rewrite it to bring it down in my problem before I create my upstairs and my downstairs, because I see that I have 2 negative exponents. When I do that, remember I keep everything positive on top that's an exponent, so that negative 125 stays on top, x to the 9th, and y to the 5th. The y to the 12th moves downstairs, as well as the x to the 4th. Order doesn't matter right now. All you need to do is check for, can I apply any bases with the product rule? And the answer is no. I have an x and a y on top. I have an x and a y on the bottom. For right now, that's as far as I can simplify this expression, so I leave it alone. You can obviously watch this video as many times as you need to go through product of power versus power to power, but you are going to go and you're going to work on the 12 practice problems. If not finished in class, it will be part of your online work, and then you'll also have your check to do as part of your online work.